Optimizing sleep is one of the most powerful ways to enhance immune function because many of the body's defensive processes are tightly linked to the sleep cycle. During sleep, especially deep, slow-wave sleep, the immune system becomes more active in specific ways that are critical for identifying and eliminating pathogens. Thoughtful. This is not simply a passive state of rest, but a highly organized period where the brain and body coordinate immune activity with precision. One of the key processes that occurs during sleep is the release of cytokines, which are signaling molecules that help regulate immune responses. Some cytokines promote inflammation when needed to fight infections, while others help resolve that inflammation once the threat is controlled. Curious. Sleep supports the balanced production of these molecules, ensuring that the immune response is strong enough to be effective, but not excessive to the point of causing damage. In addition to cytokine activity, sleep enhances the function of immune cells, such as T cells. These cells are responsible for recognizing and destroying infected or abnormal cells. During sleep, the interaction between T cells and their targets becomes more efficient. This is partly due to changes in hormone levels, including reductions in cortisol and increases in growth hormone, which create an internal environment that supports immune cell activity. Another important aspect is the role of sleep in immune memory. When the body encounters a pathogen, it not only responds in the moment, but also stores information about that encounter for future protection. This process is similar to how the brain consolidates memories. During sleep, the immune system strengthens its memory of specific threats, improving its ability to respond more quickly and effectively if the same pathogen is encountered again. Sleep deprivation disrupts these processes in multiple ways. Even a single night of poor sleep can reduce the activity of natural killer cells, which are part of the body's first line of defense against viruses. Chronic sleep restriction further impairs immune signaling and increases baseline levels of inflammation, which can make the organism more vulnerable to infections while also contributing to long-term health issues. Circadian rhythms play a crucial role in this relationship. The immune system operates on a daily cycle, with certain functions peaking at specific times. Sleep helps align these rhythms, ensuring that immune activity is synchronized with the body's overall physiology. When sleep patterns are irregular, this synchronization is lost, leading to less efficient immune responses. The timing and consistency of sleep are just as important as duration. Going to bed and waking up at roughly the same time each day helps reinforce circadian alignment, which in turn supports immune regulation. Irregular sleep schedules can confuse the internal clock, reducing the of both sleep and immune function. Environmental factors also influence how well sleep supports immunity. Exposure to light, especially blue light from screens late at night, can suppress melatonin production and delay the onset of sleep. Since melatonin also has antioxidant and immune-regulating properties, its suppression can further impact immune health. Optimizing sleep involves creating conditions that allow for deep and uninterrupted rest. This includes managing light exposure, maintaining a consistent schedule, and ensuring a comfortable sleep environment. When sleep is prioritized and stabilized, the immune system operates more efficiently with better coordination between detection, response, and recovery processes. Aligning light exposure with circadian rhythms is a powerful way to enhance immune function because the immune system operates on a 24-hour biological clock that is tightly regulated by light signals entering the eyes. These signals are detected by specialized retinal cells that communicate directly with the brain's central clock, located in the suprachiasmatic nucleus. This clock then coordinates timing across the entire body, including when immune cells are most active, when inflammation should increase or decrease, and when recovery processes should occur. Light exposure in the early part of the day plays a critical role in setting this internal clock. When you get natural sunlight shortly after waking, it sends a strong signal to the brain that it is daytime, triggering a cascade of hormonal and neural changes. Cortisol levels rise in a controlled way to promote alertness, while a timer is set for the release of melatonin later in the evening. This alignment ensures that the body transitions smoothly between states of activity and rest, which is essential for proper immune coordination. The immune system does not function at a constant level throughout the day. Certain immune responses, such as the activity of specific blood cells and the release of signaling molecules, follow predictable rhythms. These rhythms are optimized when the body's internal clock is synchronized with the external environment. When light exposure is consistent and appropriately timed, immune cells circulate and respond more efficiently. improving the body's ability to detect and manage potential threats. Disruption of this system can have noticeable effects. Irregular light exposure, such as staying indoors in dim lighting during the day or being exposed to bright artificial light at night, can confuse the circadian clock. This leads to misalignment between internal processes and external cues. As a result, immune responses may occur at less optimal times, reducing their effectiveness. Over time, this can contribute to increased susceptibility to infections and a higher baseline level of inflammation. Artificial light at night is particularly problematic because it interferes with melatonin production. Melatonin is not only important for sleep, but also has direct effects on immune regulation. It helps coordinate antioxidant defense mechanisms and modulates inflammatory responses. When melatonin release is suppressed by late-night light exposure, these protective effects are diminished, and the quality of sleep is also reduced, further compounding the impact on immunity. On the other hand, sufficient exposure to bright light during the day strengthens circadian signaling. Natural sunlight is especially effective because it is much brighter than typical indoor lighting and contains a full spectrum of wavelengths. This strong input reinforces the timing of biological processes, making it easier for the body to maintain consistent rhythms across different systems. Behavioral patterns also interact with light exposure. Activities like eating, exercising, and sleeping all send timing signals to the body, but light is the most dominant cue. When these behaviors are aligned with natural light cycles, the overall system becomes more stable. For example, waking up and going outside at a consistent time each day helps anchor the rhythm, while reducing light exposure in the evening supports the transition to rest. Consistency is key in this process. Occasional deviations may not have a major impact, but chronic misalignment can gradually weaken the coordination between systems. This affects not only immunity, but also energy levels, mood, and cognitive function, all of which are interconnected with immune health. By aligning light exposure with natural circadian rhythms, you create a stable framework in which the immune system can operate with greater precision. This allows immune cells and signaling processes to occur at the right times, improving both the speed and effectiveness of the bodies against potential threats. Maintaining a nutrient-dense diet is fundamental for immune function because every aspect of the immune response depends on the availability of specific building blocks that come directly from what you eat. The immune system is constantly producing cells, signaling molecules, and protective barriers, all of which require energy, amino acids, vitamins, and minerals to function effectively. Without consistent nutritional support, these processes become less efficient and more prone to imbalance. Proteins play a central role because they provide amino acids that are used to build immune cells and antibodies. These antibodies are essential for identifying and neutralizing pathogens. If protein intake is insufficient, the body may struggle to produce enough of these critical components, weakening its ability to respond to infections. At the same time, amino acids are involved in the production of signaling molecules that help coordinate the immune response, ensuring that different parts of the system communicate effectively. Vitamins and minerals act as cofactors in many immune-related processes. For example, vitamin C supports the function of white blood cells and contributes to antioxidant defense, helping protect cells from damage during immune activity. Vitamin D plays a regulatory role, influencing how aggressively the immune system responds to threats and helping prevent excessive inflammation. Minerals like zinc are involved in the development and activation of immune cells, as well as in maintaining the integrity of physical barriers such as the skin and mucosal surfaces. The gut is another critical component of immune health, and it is directly influenced by diet. A large portion of the immune system is located in the gastrointestinal tract, where it interacts with trillions of microorganisms. These microbes help train the immune system to distinguish between harmful and harmless substances. A diet that supports a diverse and balanced gut microbiome enhances this training process, improving the body's ability to respond appropriately to different challenges. Fiber plays an important role in this context because it serves as fuel for beneficial gut bacteria. When these bacteria ferment fiber, they produce compounds that support the health of the gut lining and influence immune signaling. This helps maintain a strong barrier against pathogens while also promoting balanced immune activity. In contrast, a diet low in fiber and high in processed foods can disrupt the microbiome, leading to increased inflammation and reduced immune efficiency. Fats are also important, particularly certain types of fatty acids that influence inflammation. Omega-3 fatty acids, for example, help regulate inflammatory responses, ensuring that they are effective without becoming excessive. This balance is crucial because both insufficient and excessive inflammation can be harmful. The immune system needs to respond strongly enough to eliminate threats, but also needs mechanisms to shut down the response once the job is done. Blood sugar regulation is another key factor linked to diet. Frequent spikes and crashes in glucose levels can impair immune cell function and increase inflammation. Stable blood sugar supports consistent energy availability for immune processes and reduces stress on the body's regulatory systems. Hydration works alongside nutrition by supporting circulation and the transport of nutrients to where they are needed. It also helps maintain the mucosal barriers in the respiratory and digestive systems, which act as the first line of defense against pathogens. Through a nutrient-dense diet, the body receives the resources it needs to maintain a strong and balanced immune system. This allows immune cells to function efficiently, communication between systems to remain clear, and protective barriers to stay intact, all of which contribute to a more effective defense against illness. Engaging in regular, moderate physical activity is a powerful way to enhance immune function because movement directly influences how immune cells circulate, communicate, and respond to potential threats. The immune system is not static. It relies on continuous movement through the bloodstream and lymphatic system to monitor the body for signs of infection or damage. Exercise acts as a mechanism that increases this circulation, effectively improving immune surveillance. When you engage in moderate exercise, such as brisk walking, cycling, or resistance training, there is an increase in heart rate and blood flow. This helps mobilize immune cells, including natural killer cells, T cells, and neutrophils, allowing them to move more efficiently throughout the body. As a result, these cells are better able to detect and respond to pathogens at an earlier stage. This enhanced circulation also supports the transport of signaling molecules that coordinate immune responses, improving overall system efficiency. Exercise also influences inflammation, which is a key component of immune function. In the short term, physical activity can create a mild inflammatory response, which is actually beneficial because it stimulates adaptation and repair. Over time, regular moderate exercise reduces chronic low-grade inflammation, which is often associated with weakened immune function and increased risk of disease. This balance allows the immune system to remain responsive without being overactive. Another important factor is the effect of exercise on stress hormones. Physical activity helps regulate levels of cortisol and other stress-related hormones. While acute increases in these hormones during exercise are normal and even beneficial, regular activity helps lower baseline stress levels. Since chronic stress can suppress immune function, this regulatory effect supports a more balanced and resilient system. Exercise also interacts with other systems that influence immunity, including sleep and metabolism. People who engage in regular physical activity often experience better sleep quality, which further enhances immune processes. Improved metabolic health, including better blood sugar regulation and cardiovascular function, creates an internal environment that supports efficient immune activity. However, the intensity and duration of exercise are critical variables. While moderate exercise enhances immune function, excessive or atypical intense training without adequate recovery can have the opposite effect. Prolonged high-intensity exercise can temporarily suppress immune activity, increasing susceptibility to illness. This is partly due to elevated stress hormones and insufficient time for the body to repair and adapt. The immune system, like other systems in the body, requires a balance between challenge and recovery. Recovery periods are therefore an essential part of any exercise routine. Rest allows the body to repair tissues, restore energy levels, and normalize immune activity. Without sufficient recovery, the benefits of exercise can be diminished and the system may become strained. Consistency is another key element. The immune benefits of exercise are not derived from occasional intense workouts, but from regular, sustained activity over time. This creates a stable pattern that the body can adapt to, reinforcing the methebit effects on immune circulation and regulation. By incorporating regular, moderate physical activity into daily life, you support the movement and coordination of immune cells, reduce harmful inflammation, and create conditions that allow the immune system to function more effectively. This leads to a more responsive and balanced system that is better equipped to handle challenges. Managing stress is essential for maintaining a strong and balanced immune system because the brain and immune system are tightly connected through hormonal and neural pathways. When you experience stress, the body activates a coordinated response involving the release of cortisol and adrenaline. In the short term, this response can be beneficial, It prepares the body to deal with immediate challenges and can temporarily enhance certain aspects of immune function, such as increasing the movement of immune cells into the bloodstream. However, the problem arises when stress becomes chronic. Prolonged elevation of cortisol begins to suppress key immune processes. It reduces the effectiveness of immune cells like lymphocytes, which are responsible for identifying and neutralizing pathogens. At the same time, chronic stress can disrupt the balance of cytokines, the signaling molecules that regulate inflammation. This can lead to a state where the immune system is both less effective at fighting infections and more likely to produce low-grade, persistent inflammation. This imbalance has wide-ranging effects. When immune defenses are suppressed, the body becomes more vulnerable to viruses and bacteria. At the same time, chronic inflammation can contribute to fatigue, slower recovery, and increased risk of long-term health issues. The immune system is essentially pulled in two directions, unable to respond optimally to either immediate threats or ongoing regulation. The brain plays a central role in this process through its interpretation of stress. How you perceive a situation, whether as a manageable challenge or an overwhelming threat, affects the schedule and duration of the stress response. This means that cognitive and emotional regulation can directly influence physiological outcomes. When the brain interprets stress in a more controlled way, the hormonal response is more moderate and resolves more quickly, allowing the immune system to return to baseline. Techniques that help regulate stress can therefore have a direct impact on immune function. Practices such as controlled breathing, mindfulness, and physical relaxation activate the parasympathetic nervous system, which counteracts the stress response. This shift reduces cortisol levels and promotes a state where the body can focus on recovery and maintenance, rather than defar against perceived threats. Breathing is one of the most immediate tools for influencing this system. Slow, deliberate breathing patterns can signal safety to the brain, reducing activation of stress pathways. Over time, regularly engaging in such practices can improve baseline stress levels, making the immune system more stable and less reactive. Social connection also plays a role in stress regulation. Positive interactions with others can reduce stress hormone levels and support emotional well-being, which in turn benefits immune function. Isolation or ongoing psychological strain can have the opposite effect, reinforcing stress pathways and weakening defar mechanisms. Sleep and stress are closely linked as well. High stress levels can disrupt sleep, and poor sleep further increases stress, creating a cycle that negatively impacts immunity. Addressing stress helps break this cycle, allowing both sleep and immune processes to improve. By managing stress effectively, you reduce the chronic activation of systems that suppress immune function and promote a more balanced internal environment. This allows the immune system to operate with greater precision, responding strongly when needed, and returning to baseline efficiently once the threat is passed. Using temperature exposure and proper hydration to support immune function is based on the idea that the body adapts to controlled physical stressors and relies on fluid balance to maintain efficient internal processes. Both of these factors influence how immune cells are activated, transported, and regulated throughout the body. Exposure to cold is a form of controlled stress that can activate the sympathetic nervous system and trigger the release of stress hormones like adrenaline. In short, brief exposures, this can increase alertness and stimulate certain immune responses. Cold exposure has been shown to elevate levels of circulating immune cells, including natural killer cells, which play a key role in identifying and destroying virus-infected cells. This response is part of a broader adaptation process where the body becomes more resilient to environmental challenges. Cold exposure may also influence inflammation. Short-term exposure can lead to an anti-inflammatory effect after the initial stress response subsides. This is partly due to changes in cytokine signaling and improved regulation of immune activity. The key factor is duration and intensity. Mild controlled exposure, such as cold showers or brief exposure to cold air, can be beneficial, while excessive exposure without adaptation can place too much stress on the system and have the opposite effect. Heat exposure works through a different but complementary mechanism. Activities like sauna use increased body temperature, which can mimic a mild fever-like state. Fever is one of the body's natural defense mechanisms, as many pathogens are less able to survive at higher temperatures. Heat exposure also increases circulation, allowing immune cells to move more efficiently throughout the body. In addition, it stimulates the production of heat shock proteins, which help protect cells from stress and support repair processes. There is also evidence that regular heat exposure can support cardiovascular health and reduce baseline inflammation, both of which contribute to a more effective immune system. As with cold exposure, the benefits depend on proper use. Sessions should be of moderate duration, followed by adequate cooling and recovery, allowing the body to adapt without becoming overwhelmed. Hydration is equally important because the immune system relies on fluid movement to function properly. Blood and lymph, the two primary fluids involved in immune activity, transport immune cells, nutrients, and signaling molecules throughout the body. When hydration levels are low, this transport becomes less efficient, slowing down the ability of the immune system to detect and respond to threats. Fluids also play a crucial role in maintaining the organism's physical barriers. The mucosal linings of the respiratory and digestive systems are among the first lines of defense against pathogens. These surfaces rely on adequate moisture to trap and remove harmful particles. Dehydration can compromise this barrier, making it easier for pathogens to enter and establish infection. Another aspect of hydration is temperature regulation. Proper fluid balance allows the body to maintain stable internal conditions, even during stress or environmental changes. This stability supports the optimal functioning of enzymes and cellular processes involved in immunity. The interaction between temperature exposure and hydration is also important. Activities like sauna use or exercise increase fluid loss through sweating, which must be replenished to maintain balance. Without adequate hydration, the potential benefits of these practices can be reduced. By using controlled temperature exposure and maintaining proper hydration, you create conditions that support circulation, cellular protection, and efficient immune signaling. These factors work together to enhance the body's ability to respond to challenges while maintaining internal balance. Using temperature exposure and proper hydration to support immune function is based on the idea that the body adapts to controlled physical stressors and relies on fluid balance to maintain efficient internal processes. Both of these factors influence how immune cells are activated, transported, and regulated throughout the body. Exposure to cold is a form of controlled stress that can activate the sympathetic nervous system and trigger the release of stress hormones like adrenaline. In short, brief exposures, this can increase alertness and stimulate certain immune responses. Cold exposure has been shown to elevate levels of circulating immune cells, including natural killer cells, which play a key role in identifying and destroying virus-infected cells. This response is part of a broader adaptation process where the body becomes more resilient to environmental challenges. Cold exposure may also influence inflammation. Short-term exposure can lead to an anti-inflammatory effect after the initial stress response subsides. This is partly due to changes in cytokine signaling and improved regulation of immune activity. The key factor is duration and intensity. Mild controlled exposure, such as cold showers or brief exposure to cold air, can be beneficial, while excessive exposure without adaptation can place too much stress on the system and have the opposite effect. Heat exposure works through a different but complementary mechanism. Activities like sauna use increased body temperature, which can mimic a mild fever-like state. Fever is one of the body's natural defense mechanisms, as many pathogens are less able to survive at higher temperatures. Heat exposure also increases circulation, allowing immune cells to move more efficiently throughout the body. In addition, it stimulates the production of heat shock proteins, which help protect cells from stress and support repair processes. There's also evidence that regular heat exposure can support cardiovascular health and reduce baseline inflammation, both of which contribute to a more effective immune system. As with cold exposure, the benefits depend on proper use. Sessions should be of moderate duration, followed by adequate cooling and recovery, allowing the body to adapt without becoming overwhelmed. Hydration is equally important because the immune system relies on fluid movement to function properly. Blood and lymph, the two primary fluids involved in immune activity, transport immune cells, nutrients, and signaling molecules throughout the body. When hydration levels are low, this transport becomes less efficient, slowing down the ability of the immune system to detect and respond to threats. Fluids also play a crucial role in maintaining the body's physical barriers. The mucosal linings of the respiratory and digestive systems are among the first lines of defense against pathogens. These surfaces rely on adequate moisture to trap and remove harmful particles. Dehydration can compromise this barrier, making it easier for pathogens to enter and establish infection. Another aspect of hydration is temperature regulation. Proper fluid balance allows the body to maintain stable internal conditions, even during stress or environmental changes. This stability supports the optimal functioning of enzymes and cellular processes involved in immunity. The interaction between temperature exposure and hydration is also important. Activities like sauna use or exercise increase fluid loss through sweating, which must be replenished to maintain balance. Without adequate hydration, the potential benefits of these practices can be reduced. When these elements are applied consistently and with proper balance, they train the body to become more resilient and efficient in how it manages internal stress and external threats. The immune system becomes better coordinated, circulation improves, and recovery processes are enhanced, allowing the body to respond more effectively while maintaining stability over time.